So let us see this problem. Arrhenius equation. Some questions, important question on based in this Arrhenius equation directly. Calculate the rate constant and half-life period of the first order reactions having activation energy 39.3 kilocalorie per mole at 300 degrees centigrade and frequency constant. So we have given frequency constant, temperature, activation energy. So we can directly calculate the rate constant. So rate constant formula is what is the formula? E to the power minus EA by RT. So here we have given E is also given, E is also, or T is also given. So we can convert into log form also. So we can write here log of K is equal to log of A, so minus EA by 2.303 R into 1 by T. So on putting this value, you can put this directly. So here you will get log of A is given here how much? 1.11. So we can write here 1.11 into 10 to the power 11. My activation energy is 39.3 into 10 to the power 3 and divide by 2.303 into R. R is given here 1.987 and temperature is 300, that is nothing but the 573 Kelvin. So if you solve it, on solving you will get here K is equal to 1.14 into 10 to the power minus 4 per second. So this is the answer. For the first order reactions having same concentration A and B, T equal to 0, use the given data to calculate the temperature at which the both occurs with same rate. That is, reaction A is equal to A into Z and B equal to Y. So K1 for first one, K1 is the 10 to the power minus 10 to the power 16 e to the power minus this one, and for K2 this value is given here. So we have to find this one. So R1 is equal to K1 into this, and for again rate second rate is equal to K2 is equal to this is the B. Now again they have given A is equal to B. This is another conditions. So in this case what will happen? Both are equal to each other. So we can write here R1 is equal to R2 when K1 is equal to K2. So we can put this value together. 10 to the power 16 e to the power minus 3000 divided by T, and this is equal to how much? 10 to the power 15 e to the power minus 2000 divided by T. So here on solving we can write here 16 minus 3000 divided by T into 2.303, and this will be again 15 minus 2000 divided by T into 2.303. So this will be equal to how much? 1 equal to 1000 divided by T into 2.303. Our temperature is equal to how much? 1000 divided by 1 into 2.303, or we can say temperature is equal to 434.22 Kelvin. So this is the answer. So this is somewhat a big question, but the question is big but the answer is not that much big. The rate of decomposition of methyl nitrate and ethyl nitrate, the two nitrates given, the here rate constants K1, K2 respectively. The energy of activation, these two reactions also given, 152.3 and 153. So 2 rate constant and 2 here activation energy given, as well as frequency factor also given. For the decomposition of these two product, methyl nitrate and ethyl nitrate, calculate the temperature at which the rate constant will be same for the two reactions. So again we have to use this formula only. K is equal to A to the power e to the power by divided by R2. So we have to use this formula only. So for methyl nitrite we can use K1 is equal to 10 to the power 13 into e to the power here given here 1523 into 1000 divided by 8.314 into temperature T. Of course ethyl nitrite, if you say it, so ethyl nitrate will be again same. K2 will be 10 to the power 14 and e to the power minus again here minus 157700 8.314 divided by multiplied by T. So this is given here. Now question is if K1 is equal to K2. If these both are equal, then we can equate these two equations. So on equating these two equations we can write here same thing, 10 to the power 13 e to the power minus here 150. So we can put this value 152,300 divided by 8.314 into T, and this is equal to 10 to the power 14 e to the power minus divided by minus 157700 divided by 8.314 into t. So this is given here. So here on solving, what we will get? We will get here 10 to the power e, and here you will get 157700 minus 152300, and this will be your divided by 8.314 into t, or we can see 2.30 3 log of, so here log of k, this is equal to how much? So here log of 10, because 10 is there, so we can write here 157700 minus 152300 divided by 8.314 into t. So on solving, this is the log 10 equal to 1, so if you solve it, so on solving you will get t equal to 282 Kelvin. So this is our answer. So the energy of activation of a reaction is 100 kJ per mole. Presence of a catalyst lowers the energy of activation by 75%. What will be the effect on the rate of reaction at 20 degrees centigrade, other things being equal? So again, case 1 you can take here. Case 1 will be K1 is equal to A to the power E. So here will be minus 100 by RT. And second, case 2 if you take here, so K equal to A to the power here E minus 25, so 100% given here by R into T. So again, so 100% or 75%, the two cases given, one 100%, one 25% left. So K1 by K2 will be equal to, solve it, so this will be E minus 100 by RT and divided by E to the power minus 25 by RT. So if you take log value, log of K2 by K1, that is equal to log of e to the power 20, that is e to the power 75 by RT. So if you solve it, 100 minus 25 plus 75. So again, if you solve it, this will become nothing but the log K2 by K1 will be equal to 75 by RT, and this is equal to 75 into 10 to the power 3 divided by 8.314 into 293. So again, log of K2 by K1. So if you take anti-log, taking anti-log, what we will get? So you will get here K2 by K1 is equal to 2.35 into 10 to the power 13. Now R is equal to concentration into power n. Okay, so again what, R2 by R1 is equal to K2 by K1, and this is nothing but this is equal to 2.35 into 10 to the power 13. So this will be same answer. So here a hydrogenation reaction is carried out at 500 Kelvin if the same reaction is carried in presence of a catalyst at the same rate. So here rates are equal. So here temperature, one is in presence of catalyst, one in absence of catalyst. The temperature required is 400 Kelvin. So two different temperature, but rate of the reaction is same. Calculate the activation energy of the reaction if the catalyst lowers the activation energy barrier by 20 kilojoule per mole. So we can write here, so in presence of catalyst, what is the reaction? Reaction is K1, because catalyst will change the rate constant. So this is equal to minus EA by R into 500. Now in absence of catalyst, so what is the reaction? If absence of catalyst, K2 will be your A is equal to e to the power minus EA by R into 400. So this is temperature is different, one is 500 Kelvin, one is 400 Kelvin. Now reactions are equal, R1 is equal to O2, this condition. So what we want, K1 is equal to K2. So we can, this two value equal to each other. So here we can write it, this is cancelled. So we can write directly here EA by directly solving R into 500, this is equal to EA dash by R into 400. So on solving here we will get here, so EA by 500, and this will be your, this is equal to EA minus 20 by 400. So here since EA minus EA dash is equal to 20. So this is the another equation. This is another equations. Why? Because if you see here, EA dash is equal to EA minus 20. This is already given here. This is the energy already given in the questions. This is given in questions. So EA minus EA dash is equal to 20. So EA is equal to how much? So here on solving, this will you will get here. If you solve this one, so you will get answer here. This is cancelling. EA equal to 20. So this is equal to 100 kilojoule per mole. Find out the percentage of the reactant molecules crossing over the energy barrier at 325 Kelvin. Given out delta at 325 is 0.12 kilocalorie, and here activation area of the backward reaction is the 0.02 kilokelvin. It is given here. So we will find out. So here delta H is equal to EA by F minus EA by B. This we know already. So here already we need to find out EAF. So EAF is equal to, so this is given here 0.12 into 10 power 3 calorie, and this will be plus 0.02 into 10 power 3. So total you will get here 0.14 into 10 power 3 calories. This you will get here. This is kilocalorie. Now percentage of molecules is again percentage of molecules crossing over the barrier. So what is the percentage of molecule crossing over the barrier? This is equal to 100 multiplied by e to the power minus 140 divided by 2 into temperature is 325. So R value given. So this is the 140 into, so this is the, if you multiply it, you will nothing, you will get here 140. So this is the EA value. So EA is given here. This is the 100. So if you multiply it, 100 multiplied by, on solving this value, you will get answer 0.8065. So percentage will be 80.65%. So this is the percentage of reactant molecule which is crossing over the barrier.